Hi, my name is Yashanand Sarika, and today in this video we are going to tell you about what we have done in our project Delta 3D printer with wireless control. This video will tell you from starting till the end how we made our printer, what all we did, what was the process that we adopted, what all we did to make this project work.
So I will tell you how we obtained the mechanical structure of the printer. First we designed the external structure on a CAD modeling software, and we cut out the designs on an MDF board. Then we assembled the MDF boards and attached the smooth rods, the carriages on the smooth rods, the idler heads, and we put the connecting rods, attached the end effector for the head. And once we attached the head, we enclosed the back panels, and we completed the mechanical structure of the printer.
Once the back panels were attached, we also had to install the acrylic sheets which help us from shielding the printer, the 3D printed models from the environmental changes. And once the acrylic sheets were done, we go to the electronics part of the 3D printer. And the electronics involves Arduino Mega. We used RAMS 1.4, which is a shield over the Arduino Mega, which helps us control the heat bed, the hot ends, and the end stoppers. All these were connected to the RAMS board, and we also had to install the extruders and the extruder motors. All the connections were soldered to the RAMS board, and the electronics was completed.
Okay, now talking about firmware. So the firmware that we use on our board RAMS 1.4 is called as Marlin. This Marlin is nothing but a G-code interpreter. What it does is that it takes a 3D model in terms of G-code file. Now this G-code file is nothing but a method in which the programmer or the user specifies where the nozzle or where the tool head should move, in how much dimension, how much it should move, so as to define that particular model. So once we get a G-code file, the Marlin takes that G-code file, interprets it, understands how much it has to move in which axis, and gives the same amount of information to stepper drivers, ultimately leading to the motion of the nozzle, thereby depositing our material and defining a 3D model.
Coming to the process flow of the working of the 3D printer, firstly the model to be printed is designed using a CAD modeling software like SketchUp, and this model is sent to a software called Slicer. The slicer which we are using is Slick 3R. This slicer will divide the model into layers, and it will generate G-code. The G-code is a set of instructions which is given to the printer, and it will instruct the nozzle to move in a particular path and deposit material layer wise to obtain the complete model. After the G-code is obtained from the slicer, we load this file into a software called Prontophase. Prontophase is used to control and monitor the printer. It will have settings, as in the home settings, to move the head up, along the X, Y and Z axis, and it will also have settings to monitor the bed temperature and the hot end temperature. We make the required settings to obtain the models.
Finally, to obtain wireless control of the 3D printer, we have used a Raspberry Pi along with Octoprint installed in it. Octoprint is a Linux distribution operating system for wireless control of a 3D printer. It provides features such as wireless monitoring, control, and we can also obtain time-lapse videos of the models. So we don't have to physically attach a device like a laptop or a computer to the printer always. We can use any device, for example an Android device like our phones, to monitor the models which are being printed.
This was a gist of our project that we did. This project, 7-semester project, is now complete, and the next iteration or the next thing that we want to do with our project is to make this project as multicolor. For that, we want to make three colors or three materials at the same time. We have proposed this project, and hopefully it gets sanctioned. If it is approved, then you will hear from us again with a new project with a new videos. Thank you.